So here we go now. This is how we calculate now the predictions in the shallow water equation. So several steps. As before, the first step is predicting the new velocities. So how does it look like? In 2 dimensions, we can point to a grid cell with J and K index. Okay. So this one here, for example, is the u velocity at the current time level n. Okay. So now if we add a correction, which comes from the force, this is the acceleration introduced by the force. Okay. And you can see that there is a gradient, k plus 1 and k. This is the horizontal gradient of the sea level elevation. And then we can project it to calculate the velocity grid at the next time level, n plus 1. And we can do something similar for the v velocity component. Here you can see it's a gradient j plus 1 minus j. So it's the next grid cell to the north. Okay, to the north minus 1. And you can do that for all grid cells of your domain. Okay, and that's it. That's what you do. First thing. So now with these updated values, or the predicted values, you can plug them into the continuity equation, the vertically integrated form of the continuity equation, and you can predict a new sea level elevation. Okay, sea level elevation. Then you might, if you want to, use a filter. Did that before, just to create a smoother output, the so-called Shapiro filter. All right, so this is how you do it. There's just one trick in here, and I want to go through that again. It's in the volume conservation equation. You have to think about which value you want to use for the total water. And we go through that again. It's called the upstream approach.